Now I've summarised what we've got so far, the equation x equals tan squared t and y equals sine t. And also in part A we found that the gradient at any point on the curve dy dx was given by cos t over 2 tan t sec squared t. And in part B what we've got to do is find the equation of the tangent to this curve at the point where t is equal to pi upon 4. So when t equals pi upon 4, in order to find the equation of a tangent, I'm going to use the fact that a tangent is a straight line, and the equation of any straight line is of the form y minus y1 equals m bracket x minus x1, an equation that you should be familiar with, where x1 and y1 are particular points on the curve and m is the gradient. So first of all I need to get my x and y coordinates when t is pi upon 4, and so what I'm going to do is substitute t equals pi upon 4 in here to get the x value. So therefore x will equal the tan of pi upon 4, and that answer is squared. Now the tan of pi upon 4, you can do it on any calculator, or you should know the result. The tan of essentially 45 degrees, which is 1, square it, that's going to be 1. Similarly, we're going to need to work out the y value, and so y would equal the sine of pi upon 4, and the sine of pi upon 4 turns out to be 1 over the square root of 2, 1 over root 2. We also need the gradient, the m value, and so we need to put t equals pi upon 4 into the equation for dy dx. So we've also got that dy by dx would equal the cosine of pi upon 4, and all of that is divided by 2 times the tan of pi upon 4 and sec squared pi upon 4. Now if you work this out on a calculator, what you'll get is 1 over 4 root 2. Okay, so that's the gradient. Now we just need to get the equation of the tangent. So I'll just move that up a little, okay, and so therefore the equation of the tangent, and make sure you tell the reader what you're doing, that is the equation of the tangent at t equals pi upon 4 is, okay, try and avoid using an equals because that would definitely be wrong. The equation of tangent at t equals pi upon 4 is y minus the y1, and the y1 that we've seen is 1 over root 2, so that's minus 1 over root 2, equals m, so the gradient is 1 over 4 root 2, okay, multiplied by x minus x1, and x1 is the 1. Now we were asked to put the equation of the tangent in the form y equals ax plus b, stating the values of a and b. So in other words, what I want to do is remove this minus 1 over root 2 then. So I'm going to add 1 over root 2 to both sides, and at the same time expand this bracket. So if I do that, we would therefore have y equals, so expanding this bracket gives me 1 over 4 root 2 x, and then 1 over 4 root 2 multiplied by the minus 1 is minus 1 over 4 root 2, and I'm adding 1 over root 2 to both sides, so we have adding 1 over root 2. Cleaning this up further, I'll just scroll that up. Okay, we'll take it up to there. what we have is y equals 1 over 4 root 2x, and here we have minus a quarter of 1 over root 2 plus 1 whole one of 1 over root 2. So that's going to leave me with 3/4 of 1 over root 2. So that's plus 3 over 4 root 2. So I need to get this, as I say, in the form y equals ax plus b, and basically it's in that form at the moment, but I don't like the fact that we've got square roots on the bottom here, and so what I'm going to do is rationalize each of these two terms. That is by multiplying top and bottom by root 2. And if I do that on this one, I'm going to have root 2 on the top, okay, and on the bottom would be 4 root 2 times another root 2, and so that's 4 times 2, which is 8. So we've got root 2 over 8x, and if I do the same, that is times top and bottom by root 2 on this term, I will have 3 root 2 on the top, and on the bottom I would have 4 times root 2 times another root 2, which is going to be 4 times 2, which is 8. And so therefore we have that y is identical to ax plus b, where clearly a is equal to root 2 over 8 and b is equal to 3 root 2 over 8. And that brings us to the end then of part B.